So, what if the single biggest threat to our physical world, our power grids, our factories, isn't what you think it is? Today, we're going to deconstruct a really high-stakes proposal for a new kind of security, what it calls a mandate for resilience. Let's dive in and break down how it makes its case.
Okay, boom. Right out of the gate, the stakes are laid bare. This one sentence changes the entire game. We're not just talking about hackers stealing credit card numbers anymore. We are talking about the actual physical systems that keep our world running: power, manufacturing, water supplies. The whole point here is that a digital threat can now cause a real-world physical disaster.
All right, so how did we even get here? How did we end up in such a dangerous spot? This first section really unpacks the history of it all, revealing what the source material calls an invisible crisis, a problem that's been quietly growing right under our noses for years.
For a long time, the thinking was pretty straightforward. You had your normal computer networks, that's IT, and then you had the heavy machinery that actually ran the factory floor, what's called operational technology, or OT. And the golden rule was to keep them completely separate, to create what's known as an air gap. Literally a gap of air between the two systems. It was supposed to be a fortress wall, but, well, that wall is gone.
And this slide just lays out that shift perfectly. On the left, you've got the old myth. Everything's isolated. Everything's safe. But the reality today, on the right, is what everyone calls convergence. See, to make our systems smarter and more efficient, we've connected the IT and OT worlds. And the huge, unintended side effect? We've created this massive new playground for attackers, putting our most important physical systems directly in the line of fire.
And that, right there, is the key takeaway. A security breach in this converged world isn't about someone losing a spreadsheet anymore. It's about a pipeline bursting, a power grid going dark, or an entire assembly line grinding to a halt. The digital risk has morphed into a physical one.
The problem is, our old ways of checking for these dangers just can't keep up. Now, what's so powerful about this slide is how it shows you the problem with manual security tests. You get a quick snapshot in January, and then another one in July. But what on earth is happening in those huge gaps in between? New vulnerabilities pop up, systems get updated, and for months at a time, you are completely flying blind, totally exposed.
And this exposure is made so much worse by the hardware itself. A lot of these core control systems, these little industrial computers called PLCs, programmable logic controllers, they're decades old. They were designed way before anyone was seriously thinking about cybersecurity. So get this, a lot of them don't even have basic encryption. This creates a giant blind spot. We literally can't see the dangers piling up, which leads to this really stark conclusion from the source material. We are simply running on hope.
So, after painting that pretty grim picture of the problem, the pitch introduces its solution. And it's framed not as just another tool, but as an entirely new hero in the security story, a digital workforce.
And here it is, the OT Pen Testing Multi-Agent System, or MAS for short. Now, pen testing is just short for penetration testing. Basically, it's where you ethically try to hack your own systems to find the weak spots first. This MAS is designed to do that automatically and continuously, 24/7, plugging all those dangerous gaps we just saw on that timeline.
So what's the magic behind it? The technology is called Agentic AI, and this is not your standard chatbot. These are highly specialized AI agents that come together to form a kind of digital workforce. The key abilities here are memory, reasoning, and, this is the most important part, the ability to actually work together to solve complex problems, just like an expert human team would.
And that brings us to a really critical distinction. This system doesn't just spit out a messy list of alerts for you to figure out. No, it provides what's called operational intelligence. It doesn't just see the data, it actually understands the context of the physical world it's supposed to be protecting. Here is a perfect example of exactly what that means. A simple, old-school scanner might just tell you, hey, port 502 is open. Okay, so what? This system, on the other hand, knows that on this specific type of Siemens PLC, an open port 502 could let an attacker change the control logic, which means they could literally hijack the machine. That is the difference between raw data and real intelligence.
Okay, but this all leads to the million-dollar question, right? How can we actually trust an AI with something this important? This next section is all about peeling back the layers on the tech to see how that trust is actually built from the ground up.
First off, this thing isn't some chaotic swarm of AIs running wild. It's built on a highly organized hub-and-spoke model.
There's a central root agent that acts like the project manager, or, a better analogy, a central nervous system. It directs and coordinates all the other specialized agents. This ensures there's always centralized control and precision in everything it does.
And second, its process isn't random at all. The AI is programmed to follow a super strict 9-phase workflow that meticulously copies the exact methods used by elite human security teams. It's basically taken their expert playbook and automated it, so it can run around the clock, nonstop.
So this brings us right back to that central question. It's one thing to say the AI is organized and methodical, but how do we know its conclusions are reliable? How is trust actually baked into the code itself?
And the answer presented is this concept called the refinement loop. The core idea here is that trust isn't an afterthought or a feature you bolt on later. It is a core component, engineered directly into the system's architecture from day one.
So let's break down how this loop actually works. It combines a powerful memory, so the AI understands context and history, with an internal feedback system. You can almost think of it like a built-in peer review process. One part of the system is constantly double-checking another's work, refining the findings and catching potential errors long before an answer is ever presented. The whole goal is to create a system that's incredibly reliable.
Okay, so having laid out the problem and the technology, the pitch moves into its final act. This last section reframes the whole conversation. It stops being about a technical choice and becomes a much bigger strategic one. So, the most crucial point here is that this multi-agent system isn't being pitched as just another piece of software to add to the pile. It's being positioned as a fundamental strategic asset, something absolutely essential for the long-term health and resilience of the entire business. And this slide sums up those key strategic advantages beautifully. First, you get continuous, 24/7 security instead of just sporadic spot checks. Second, it allows you to have a proactive defense, finding and fixing holes before they can be exploited. And third, it helps solve a huge real-world problem, the critical global shortage of qualified OT security experts.
And this brings the entire argument to a head. The choice is presented as a very stark contrast. On one side, you have the status quo, basically relying on hope with reactive, spotty security that leaves you wide open to disaster. And on the other side, an investment in verified resilience, a proactive, continuous, and intelligent defense that actually makes your operations secure and resilient.
And the final ask here is actually really smart and low risk. It's not, hey, let's deploy this everywhere all at once. The recommendation is to start small, with a pilot program on a digital twin. That's basically a perfect virtual replica of the real-world factory or power plant, so you can test everything out in a completely safe, simulated environment first.
And we end on this final, really powerful question. While this whole pitch was about securing industrial systems, the underlying theme applies pretty much everywhere now. In a world where everything from our cars to our homes is getting connected to the internet, it really forces us all to think about the invisible risks we might be creating and what it truly means to be secure.